So notations used in the study of deep neural networks. So let's say we have been given a data set with n data points like this. This is data point 1, which is x1, y1, data point 2, x2, y2, data point 3, x3, y3, so on and so forth, data point n, xn, yn. So these are the inputs, x's are inputs, and these y's are the labels or outputs or classes of these inputs. So this y1 is class of x1, or y1 is the output given x1 as the input. y2 is the output when x2 is given as input, or y2 is the class of this data point x2, so on and so forth. So this is a data point, right? Data point 1, data point 2, right? Let's say we have this data point xi comma yi. I pick a data point randomly, ith data point xi comma y. Now the point to note is this xi or xth data point has, let's say, d features, or it is a d-dimensional data point. For example, if this has d features, then I can represent this xi as xi1, xi2, xi3 up to xid, right? So this ith data point or this ith input has d features xi1, xi2, xi3, xid. Now this x1 can be represented like this: x11, x12, x13, likewise x1d. x2 can be represented like x21, x22, x23, and x2d, right? So this is data point, second data point, and this is first feature of this second data point. So here this is second data point, second feature, second data point, third feature, second data point, this is second data point and dth feature. So first data point, first feature, first data point, second feature. So this is ith data point, first feature, ith data point, second feature, ith data point, third feature, so on and so forth. So the notation is, for xi, I am representing xi as xi1, xi2, so on and so forth, xid. So this I represent, it's an ith data point. This one represents, it's the first feature. So if I write this as xij, right? So this means I can write this as xij, ith data point and jth feature, ith data point and jth feature. Okay. So now with this knowledge, let us give ith data point as input. So this is, let's represent this input. Let's say there are 4 features for simplicity. So ith data point, first feature, ith data point, second feature, ith data point, third feature, ith data point, fourth feature. Now these inputs are given to, let's say, 3 neurons. 3 neurons we are giving input, right? Let's say we have 2 neurons here and 1 neuron here, right? So this input I am giving here, here, and here. This input I am giving here, here, and here, right? So this input I am giving here, here, and here. This input I am giving here, here, and here. So this input, the output of this neuron is given here as well as here. The output of this neuron is given here as well as here. The output of this neuron here is given here as well as here. The output of this neuron is given here and here, and this is the neuron from where we get final output, and let's call this output as yi, because this was ith data point, so that's why this is ith output, right? So output corresponding to ith input. So let's call it as yi hat, because this is not the actual output. Actual data point was xi comma yi, right? So this yi is the output produced by this neural network. Y hat is the output produced by this neural network. This yi hat is exactly equal to yi. That means this data point is producing the output very accurately, right? So now let us say, let's represent the function here. Let us, this is called as input layer. This layer is called as input layer. This is layer 1. This is layer 2, and this is layer 3, or output layer. This is also the output layer from where we are getting the output. Now this neuron, I can represent the function this neuron like this, F11. This one stands for, this is first layer. This is layer 1, actually this is layer 1. This is first layer, first neuron. F12, first layer, second neuron. From the top I am counting neurons, right? This is first layer, third neuron. This is second layer, first neuron. This is second layer, second neuron. This is third layer, first neuron, right? So the representation for the function or this unit, neuron unit, is like this: Fij, Fij. This is the layer number, and this is the neuron number from top, right? So that is how we can represent a function or neuron, right? Now let's see how do we represent output of this neuron. So output of this neuron is represented like this, O. Now this output is O11, exactly similar to this notations here, 11, right? Because this is output of this neuron 11, right? So this is also output of this neuron 11, right? So this is output of neuron 12. This is output of neuron 12. Now this line is output of neuron 13. This line is output of neuron 13, right? So this line is output of neuron 21. This line is output of neuron 22, and this line is output of neuron 31031, which is similar to yi hat. Okay, now we have weights here. Every edge has a weight. So weight here can be represented like this: W. Here we write superscript as the layer in which this weight is going. So this weight is going in layer 1. So layer this, that's why I can write this as W superscript 1, and where it is going, from 1 to 1, right? So from 1 to 1, right? So that's why this is W11. So this this talks about the layer in which it is going. This talks about the from which neuron or from which input it is going, and this talks about to which neuron it is going, right? So in general, if I write before that, let me complete this. This is W1, 1, 2. This is input 1. It's going to second neuron in the next layer, right? So similarly, I can write this as W1. It's going to layer 1. In the layer 1, where it is going to neuron 3. That's why this is 3, and from which input it is going? It is from 1. This is 1, right? 1, 3, right? So in general, if I write weights will look like this. W, this is, let's say this is K. It's this weight is going to kth layer, right? And this is I, J, from which neuron or from which input to which neuron? From and to. This is from and to, right? So from to, right? So for example, here if I write weight on this weight is going to layer 3. This is layer 3. So W3. Now it is going from first neuron here in this layer to the first neuron here. That's why W311. First neuron in this layer to the first neuron in this layer. That's why 2 from is 1 and 2 is also 1, right? So WKIJ means weight W is going in kth layer from ith neuron to jth neuron. So these are some notations which will be quite handy when we'll dive deep into the study of this deep neural networks. So now if you observe one more thing here, these edges are going in this direction, right? So these edges are going in this direction. All the edges, these are input edges, right? So this is There is no edge which is going in the backward direction. All the edges are going in the forward direction. Right? The another thing to note is, or another point to note is, this input is connected to all possible neurons. This input is also connected to all possible neurons. So similarly, this output is connected to all possible neurons in the next layer. This output is also connected to the all possible neurons in the next layer. So when we have such full connections, all connections, such network is called as fully connected neural network. Fully connected neural network. So these two layers are called as hidden layers because they are in between input and output layer. This is input layer, this layer is input layer, and this layer is output layer. So the layers between input layer and output layer are called as hidden layers. So these are the notations. We'll use the notation for studying the other concepts in the deep neural network course.